All right, good evening, everyone. How's everyone today? All right, so today we will start by going briefly over chapter 6, and then we will go briefly also over chapter 3, and then we'll take a quick break and then come back and we will go over uh, module 6 in Access, and then we'll take the exam. So Vic already has taken the exam. It took him only half an hour. So I don't want to uh, make it sound too easy, but or too difficult. But I'm sure that you all are prepared enough for it, and so it is shorter than the second exam. So the second exam we have more content to cover. This time we have very little content to cover. So then, whenever you are done, if you are done within 10 minutes or half an hour, you feel free to leave afterwards. So now, before we start, I always like to start by giving a quick review of where we are so far. So what we have done so far is that we talked about the system development or the system analysis, and we define what we really mean by system analysis. And we said the system analysis and design refers to creating and the creation and the maintenance of an information system. And we said that we are going to utilize the classic methodology for system analysis and design or for creating an information system, which was system development life cycle. So the system development life cycle consists of a couple of steps or phases that you can think of. So the first step was the system definition, in which we looked at what is actually the problem that we are trying to solve. And when we define the problem, then we were able to suggest objectives of the system that we are going to develop. And then we were able to define and identify what is in scope of the project, what is out of scope of the project. We also identify the tangible versus the intangible benefits of the project that you are working on. And also, you define or you were able to identify the phases or the major tasks that need to be taken throughout the project, and also you were able to allocate time and resources to it. So you were able to allocate resources in terms of labor, and if you chose to allocate also costs, you were able to do that as well, if you chose to. But you were able to allocate cost or allocate labor, and you allocated also time. And then when you decided which task needs to be preceded and the sequences of those tasks. And then you actually came up with a Gantt chart using Microsoft, or you used project software. You came up with the Gantt chart, which actually created for us really nice critical path. And that critical path, basically the red line, told us or tells us that whatever task that is within this red line, we will not be able to delay anymore. But if there is anything that in the blue line or any other line, then it is flexible. We can delay it. So the output of the first step was the project management or the project plan, which was in the form of a charter that you submitted and a Gantt chart. Then we moved on to the next step, which was the requirement analysis. So during that requirement analysis, what we really did is that we looked at the different techniques that we can use to extract user requirements. And what we did, one of those tools was questionnaire. So we didn't have to use that because we were able to meet or interview the end user. And we were all able to interview the end user to extract as much user requirement as possible. And then we also, another technique was observation. So we got the chance to have a little bit of observation last time using Second Life. So you were able to see the facility and the workflow, and you watched also some of the patients here. And the third observation, or the fourth actually technique was exactly, which was very beneficial and very helpful. So you looked at the existing forms, which helps you kind of identify some of those data elements and the user requirements. You examined also the request for proposal that has a lot of information for you. So it saves you a lot of time to extract those user requirements. And also you looked at those files that had snowmen, they had ICD-10, and also they had HL7 and so on, undiagnosis and so on. So you did all of those, or utilized all of those techniques to come up with user requirements, and you introduced them to the end user using mind map. So far, what we have done is we came up with a data model, you can say, using mind map to make it easier for the end user to understand. And the end user now will give you feedback whether to approve those requirements that you identified or not. And I'm going to do this really soon, within 2 days, I would say, at the latest. And then when we have that approved, which was actually, we called it a data model using mind map, then we will move on to what we will call it database design. So the data model that you created, you can think about it as a conceptual model. So conceptual model, it is like an ERD diagram that still doesn't have foreign keys and it doesn't have a lot of logic behind it. But that's how we can think about it. So today we will cover the component design, which the component design normally consists of 3 designs, and we will talk about those 3 designs. The conceptual design, the logical design, and the physical design. So what you have submitted so far was the conceptual design to some extent within the terminologies of the end user, but you will put them in an entity relationship diagram for the logical model. And then you will decide where to put, you will also and that is actually the assignment for next week. So we will talk about it today. And then you will also identify, if you chose to, we will talk also about the physical model today a little bit. So if you chose to include some elements of the physical model, feel free to do that. If not, you can wait for not this next week, but the following week, where we will, but today we will talk about both, the logical model as well as the physical model. So again, the system analysis and design books identifies those 3 types of designs. We have the conceptual design, logical design, and physical model, or physical design. And as you can see here, kind of a qualifier is that what we will talk about today is a logical design as well as some elements of the physical design. So what do we mean by the physical design is that when we have a logical design that has some elements such as the data type, data dictionary, that allow us to implement that model into a physical table, into a physical database. But so far what we will be talking about both of them. So what we have done so far, let's say that we have created a mind map, and then let's assume that you put them into tables, into entity relationships. So that was called data models, which is exactly what we talked about last week when we said those are the entity relationships, and we talked about the maximum cardinality versus the minimum cardinality. And let's also kind of recap what we did about maximum cardinality versus minimum cardinality. And we said about the maximum cardinality is that there is a one-to-one maximum cardinality, and there is a one-to-many maximum cardinality, and there is also many-to-many maximum cardinality. And then we said also there is, for minimum cardinality, we have 0 to 0, we have 0 to 1, and we have 1 to 1. Those are the minimum cardinality. And we said when we have a 1 cardinality in one entity, that means it is mandatory or required. That's how we enforce it in the physical design. And if it is 0 or an oval shape, that means it is optional. So it can be null. And we will talk about null and not null today, which will help us kind of understand the physical model. So that's what we talked about last week in terms of cardinality. And today we will go a step farther and we will transform those entities into tables. So this is kind of a design step. You can think about it in terms of evolution. We are evolving this design from an entity into a table. And the table has some characteristics that we need to actually make sure that they are there. Yes?
I have a question about cardinality. If you have an open circle and then the closed seat,
Okay.
would you say
The same side?
yes, the same side? Would you say 0 or 1 or many, or would you say 0 or many?
0 or many.
Okay.
Very good question. So you can say 0 or many because 1 would be implicitly, part of the many.
Okay.
Yeah, very good. You're good. So when we transform the entity, we need to transform it into a table, and we need to take into consideration the following. So not only the name, we will call it an entity, or from an entity to a table, but also the identifier of that entity, we will call it a primary key now. And then we will need to identify alternate key or candidate keys, and we will need to also specify the properties of the column or the field. So now, instead of attributes for the columns, we will call them fields or columns. So we will not call them attributes anymore in the logical design or in the database design. And then we will identify whether null status is applies to that particular field and also what data type. We'll talk about them in a little bit. And if there is a default value for that attribute or not. And then we will talk about data constraints that will help us understand the value of database. Then to verify normalization. So the second step is to decide where to put the foreign key. So there are rules of thumb for where to put the foreign key in which table. And I noticed that the book doesn't explicitly mention them, but I would recommend that you take notes about them because I'm going to tell you what they are. It will make it much easier for you. And we'll talk about them in a little bit. So now let's look at the first step. First step is we will transform entities into tables by adding the key. For example, here, if we are using Microsoft Access, it allows us to name a column as a primary key by highlighting it in design view and then clicking on the key. So also Microsoft Access allows you to have composite primary key. And we'll talk about that later, but if you haven't done it before, you can highlight two fields in the table or in design view. So you can highlight both columns and then click on the key sign in order to have composite, for example, in Microsoft Access. And I will explain this later. So we might not need it now until we start building the tables themselves. So the first step is to make sure that we identify, or we call the identifier a primary key instead. So how can we say what is the ideal primary key? So there are some rules. Ideal means it doesn't mean it has to be. So an ideal primary key is numeric and short. So those are kind of the what we mean by the ideal characteristics of a primary key. And then we have a surrogate key. And we will talk about surrogate key in a little bit. Surrogate key is a key that is created by the system itself for you. It doesn't have any specific meaning, it doesn't have a meaning, but it is very helpful. And we will talk about how you can utilize the surrogate key in your system or in your project. So another thing is we need to specify the alternate key. So what do we mean here by alternate key? Alternate key, you can think about them as any potential primary keys. Any potential primary key is called candidate key or alternate key. So, for example, as an employee at OU, in the table in their database where they are saving my data, they have an employee ID as my primary key. And also, they have a social security number, and that can be an alternate key, because nobody else in the whole United States has my social security number. My email address can be a potential primary key as well. My phone number, not my full number, but my cell phone number can be a potential or an alternate key.
Do employees, faculty also have a place where you might be cards? So like we have student ID numbers, do you have an ID number as well?
Yes, so ID number, and I need to go to account or my account to figure it out, but yes. So for example, when we come here, we have to use our ID to get to the elevator after hours. So yes, to answer your question, yes.
We have a composite code.
You can have a composite alternate key as well. So what we mean by a composite alternate key is that if we have together, they make our table or they identify every record in the table unique. So, and we will look at one example in a little bit. But now when we look at the notation that we have here, we have AK, which stands for alternate key, and then we have n.m. So what do we mean here by n.m? The n stands for the order of that alternate key. If we have, let's say, 3 alternate keys, one of them is composite key. So the composite key has 2 or more keys or consists of 2 or more fields. So in that case, the N will stand for the first alternate key, and then the M will stand for the number of the column of that alternate key. If it is composite key, that means it has 2 columns, the first and the second. So we will have, and this is how it will look like if we have it in a table. So in the first table, you can see that email is an alternate key, and 1 is the order of the alternate key, because we have only 1, and it is the first alternate key that we have in this table. And the other one stands for the column. So the email is column number 1 for that particular alternate key. In the other table, if you look at it, we have name and city. Both of them, they are composite key. So both of them, they are the first alternate key together. So that's why we have 1, 1 at the beginning before the dot. Standing for that, this is the first alternate key because they are composite keys. And then for name, we have .1, which means this is the first column of the first alternate key. And then for city, we have .2, which means this is the second column of the alternate key, the first alternate key. Is this clear for everyone? And then we have email, which stands basically, it is the second alternate key, and it is the first column of the second alternate key. That's why we have 1. So very clear, right? So now we need to also decide about the null status. Yes.
If the primary key is set to not also required, why would you if you have that primary key in the system?
So alternate keys, it is good to identify them, but they might not be required. So in this case, if they are not required, actually the book discusses this in elaboration. How can we ask or identify a non-key as an alternate key, but it is not required to be, it might be blank. So that's kind of a discussion for database designers, but still helps with that, to decide, to designate it as an alternate key. But for me, if I'm designing a database, I will definitely make it required because it doesn't make sense to call it an alternate key, but it is not required. So in this case, the alternate key is the email. But in some situations, let's say in this project that you are working are mostly elders, or elderly. And elderly might not have an email address. Maybe it's not, they didn't get into emails yet. So in this case, it's an alternative. The majority of people might have an email, but some might not have. So in your project, for example, if you want to include email, it can be optional. But uniquely, yes, it can uniquely identify each record, but it is not required, so it's not as reliable as the primary. So I will focus on the primary key per se. So now you have seen that how we can put or write in a table the notations for null versus not null, and also alternate key. So another thing is we need to, which is actually for the physical design, is to decide and identify what are the data types or the property of the table. So what are those data types? Those are the common ones that you can utilize for your own project when you submit a physical model, which is with the data dictionary. You can either use those or you can utilize the ones or the data types that are provided in Microsoft Access, whichever makes it easy for you. But to make it easier for you to understand, so CHAR here stands for character. So in general, we have numeric versus text. Kind of those are kind of the major two types. And there are other types, but those are kind of the two major two types. So we have char, which is basically text data type versus numeric data type. So a car, when we use car, the first dot or the first bullet, car, and in parentheses, this stands for this field has character data type and fixed number of characters. And it means that it has to be filled out because it is fixed. It's not variable. So an example of car and then with an N, look at the phone number. If you look at the phone number, we allocated to it 15 characters and it is fixed. So that means it must have 15 characters, otherwise it will not allow you to move on to the next record. So this is what we call it domain integrity also. So we are making sure that you are filling out that exact number. Otherwise, it's going to be misvalued. And people will try to reach out to that patient, for example. They will not be able to reach you if they use one character. So now, character and fixed number of characters that we allocated to it. And then what is N R and then N? So the capital N. So the capital N here refers to Unicode standards. So basically this is the international Unicode standards, which basically allows us to use international characters. So for example, let's say that in my email, if you notice also the email has N bar car, I can utilize or I can include Arabic characters in my email. So the N, which means Unicode, international Unicode, allow me to include any other characters that are foreign. So Russian characters, Chinese characters, Arabic characters, they are part of the Unicode. So now that's where you will include the N. If you think that some people might use Unicode characters. Now when we look at the varchar, so the var basically stands for variable character. So if you notice now the first name or the employee name has varchar and then 50. So the 50 means here that we are allocating in the memory 50 characters for this particular field, up to 50. So it can be 1, it can be 2. So some names can be 3, like Joe, right? J-O-E, for example. That should be fine. That's what we mean by variable. So it can be 1, 2, 3 letters or characters all the way up to 50. So everyone is clear what we mean by those different characters and properties?
You say on the chart that it has to be like 15, but if the bar chart you can distinguish, like it could be with
So when we say var car means it is variable. It can go from one, it can be, yeah, from 1 all the way to 50 because we allocated 40, 50, but it can vary. Very good. So as I said, you can utilize those ones, and this is kind of an example how your physical model will look like. You will put, for example, the name of the attribute and then the car, whether it is a null or not null, and whether it is an alternate key or so. And then I included for you here Microsoft Access 2013. 2016 might be a little bit different, but this one at least includes short text. I think it's still used in Access right now. And the long, usually, I would use long text if I am using a comment, but the short is reasonable because it's up to 225. Is it 255 characters? Yeah. So I would use short, long only for comment or for something that is really long, and then number. It is very straightforward. And as long as you use one and you are consistent with it. So whether you want to use the car or you want to use this one will be fine. As long as you are consistent with it. So also default. This is part of the data dictionary that you will submit. I actually provided you with a template for data dictionary in Excel that is used by professionals. And this data dictionary, the first page, has kind of a log. Who has made changes the latest? And we need to put to keep a log of the changes and the dates when they were changed. So that was kind of the first sheet, and then the other sheets where you will put every table that you have. So the attributes of each table, and then you will put, for example, the name of the attribute, the data type, and then description about it, and then you chose to have a default value for it. So in your project, for example, it will make sense to have a default value for, let's say, assessment data. So as soon as I come and open the database or the system as an nurse, I need to be able to go to the main menu. Let's say that I want to conduct an assessment for a certain patient. I can just click on that button. That will take me from the main menu to the assessment table. And the assessment table is already pre-populated with the time and date. So we will use the now function to pre-populate for us. The default value will be now, that moment that I open that assessment. So it is very handy. Some people, they use it for states. Let's say if you have Blockbuster, I haven't seen any Blockbuster stores anymore. But if you have Blockbuster, for example, and we all from Norman are renting, then it makes sense to have Norman as the city and Oklahoma as the state as default instead of putting that from scratch. But you get the idea. So another thing that database provide us with is what we call it here data constraints. So data constraints include domain constraints. So what we mean by domain constraints is that for every field, let's say the first name, we should include only first name. For phone numbers, we should only be allowed to only insert phone numbers, not letters. And you can, in some cases, you can actually enforce domain constraints by using the input mask. So we all have used the input mask. So you can use it for zip codes, for phone numbers, and so on. So it is very handy. It doesn't allow us to enter any different values, although, for example, let's say phone number is short text, kind of data type. But if we have that input mask, then it will not allow us to insert like A or any other letter. So the second one is the range constraint. So we can actually also use the range constraint. For example, this field has to be greater, so you can just say validation greater than something. So date cannot be less than, date of birth, for example, cannot be less than certain. And then you have the intra-relation constraint. So we did this actually last week, the intra-relation constraint, where we say that the insurance amount should not be greater than the invoice amount. So we did this validation rule. It was very easy using Microsoft Access. And then the interrelation constraint, this is what we call it actually here referential integrity. So what we mean by referential integrity is that the foreign key, since it is, so the foreign key value has to be one of those values that exists in the primary key. So when we enforce referential integrity, it doesn't allow us to enter any value in the foreign key that does not already exist in the primary key. And that's why we will always be using lookup for foreign keys. That way, we should be able kind of to use that drop-down list that has all the primary keys for us, and we can select it from there, or we can type it. And we will learn today about the combo box, which allows us actually to drop down, and we can select from a drop-down, or we can type the value, and then it will populate for us. So those are kind of the data constraints that can be done, that we can do, and then we can verify normalization, and we will learn about normalization today. So we already talked about those. So now let's talk about where to put, which is the second step in converting or transforming data models into database design, is making sure where to put the foreign key. So those are the rules of thumb that we are going to learn today. So if we have a one-to-one relationship, so maximum cardinality is 1-to-1, and the minimum cardinality is 0-to-0, in this situation, you can put the foreign key in either table. So as a rule of thumb, you can put it in either table. If we have a maximum cardinality 1-to-1 and a minimum cardinality 0-to-0, we can put it in either table. It will not be a problem. Now, in the second situation, if we have a 1-to-1 maximum cardinality and we have a 0-to-1 minimum cardinality, in this situation, we will need to put the foreign key in the 0 side. So that's the rule of thumb, the 0 side. So now, can you think about it logically? When we say that every salesperson is assigned to one and only one office, so that means every salesperson has to have an office. It's mandatory. That's why when we put the foreign key in the salesperson, so the sales or the office number will be populated all the time. Will never be null, or will never be left blank. However, if we put the salesperson in the office table, we say that every office might be occupied by a salesperson, and some offices might not be occupied. So that means, let's say we have 10 offices and we have only 5 salespersons. So only 5 are assigned or worked on, and 5 they are not. So if we put the salesperson attribute or field in the office table, then they will be populated in 5 records, and the other 5 it will be blank. So that is a waste because we are allocating in the memory that space and we are not utilizing it. So it makes better sense to put it in the salesperson. So everyone is clear why we decided to do it that way. So logically it makes sense, but you can also memorize it as a rule of thumb. If we have a 1-to-1 maximum cardinality and 0-to-1 minimum cardinality, it is the foreign key goes in the 0 side. So now, what if we have a one-to-many relationship? So when we have a one-to-many relationship, regardless of the minimum cardinality, we should always put the foreign key in the many side. So that's kind of a rule of thumb. If we have a one-to-many relationship, regardless of the minimum cardinality, we always put the foreign key in the many side. So now, what if we have a many-to-many relationship? So we talked about this in the first day of class, but we can talk about it because today it's time. If we have a many-to-many relationship, where should we put the foreign key? Do you think we should put it in the many? In which side in this case? Anyone has a good idea? Or want to have a suggestion? So,
Oh,
okay.
associated dependency.
Excellent. Yes. So we create a new table in this case. So we need to create a middle table, and there are so many different names for that middle table. So some people they call it junction table, some people they call it associated table, some they call it association table, some they call it intersection table. But today we will use only two terminologies: the intersection and also the association table. So in this example, we can create an intersection table which will combine or will consist of the primary key from both tables. So we call that intersection table. So now, if you look at this table, the middle table that we created, or the new table that you suggested, we created that middle table and we called it, actually it is called intersection table because it consists of the primary key of those two tables that it connects. Another thing that you will find very helpful when you are developing or designing your logical model is that if you have a many-to-many relationship and you created a middle table, intersection table, or association table, the many side is always in this intersection table. So that's kind of a rule of thumb. Okay? Makes it easier. That way you don't get confused. It's always, and those intersection tables are really helpful. If I have an intersection table or association table, I will not use a surrogate key at all. And we will find out why it is very helpful when you build a database and you try it yourself. But for now, so the second name of this table, we call it association table, but it is a little bit different from the intersection table because now we have a non-key. So let's look at two examples of every resident will have many phone types, and every phone type belongs to many residents. So now we have a many-to-many relationship. We can create an associated entity where we will have, let's say, the phone type ID and the MRN ID, which is the patient ID, as the composite primary key. And then we can put the phone number as that non-key, right? Because you might have multiple numbers for phone numbers. And but now every record will be unique.
Wouldn't it be a good idea for every record in that table to also have its own unique primary key? Because like a resident could have multiple cell phones or something. So if they have patient one, cell phone is like code two or whatever, that patient one and two cell phone numbers, they would have the same key unless you created its own primary key.
So if you think about it, let's think about it that MRN1, and I have three phone numbers, three phone types. I have a cell phone, I have work phone, and I have a home phone. So in that associated table, what I will have, so I will have my MRN, which is 1. So in the first record, in the first row, I will have 1, which is me. And then the first type is the cell phone. And then I will put the phone. And then I will have 1, and then I will have home phone. Still, the primary key is unique. And then the third one is 1, but the fourth one is work phone. So now I have 3 brackets, and they have both 3 of them are unique. So I don't need to have kind of a surrogate key by because this actually allows me, just in case I made a mistake, I try to create, let's say, another cell phone entry for me. It will not allow me to go in. It will tell me, it will pop up actually an error message telling me that this is repeated or redundant. So that's why we use this one to enforce what we call non-redundant. So very good question. So now, if we have multi-values, then we create kind of a separate table for it. And so then again here, we will skip those. And I need to take you to one step here, is cascading updates. So the book talks about cascading updates and cascading delete. So, and enforcing when we right click on the relationships, so you can enforce preferential integrity, cascade update, or cascade deletion. So you might have noticed that when we do that, we always select only the top options. We don't select the cascade delete because it's problematic. You need to know which one is the strong one, which one is the weak one. To avoid all of that, let's just focus on the first two: enforce referential integrity and cascade update. That means cascading update, that means that if I make changes, let's say I already have a lot of entries in, let's say, in the phone type, because in that case, MRN is a foreign key in the resident phone type table, which is kind of the association. Let's say I have a lot of entries there. And all of a sudden, I decided to change my MRN number. Although it's not, as we say, the primary key should not be changeable, it should be fixed. But let's say for some reason we made changes to it. Then if I enforce cascade updates, then whatever I change in the primary key, it will be automatically changed in the foreign key. So that makes life much easier. And that's one of the benefits of using database rather than spreadsheets. Kind of similar to this one. So you will have the column name, and then you will have the phone type or the column type or data type for it, and then whether it is a key or not, null status, and remarks. So remarks are like this. What do you want us to put in the notes or remark? So you can put whether it is alternate key, you can put any other information that you feel necessary. So that was the first one. So now let's move on to the next chapter. So in this chapter, what we will be talking about is the relational model and the normalization. And also the normalization we will practice more next week. But today we will go briefly over why we use normalization or when do we use normalization. You remember the first day of classes when we covered the first chapter, we talked about the different situations when to use what depending on the type of database or system that you are developing the database for. So we design a database if we have a new system or that it has not been, or we are going to build a system from scratch, then we use entity relationship diagram. That's kind of what the book suggested for us the first day. So if we are building a system or designing a database from scratch because no other digital tables or were there before, then we use it for us to design a If there is, if there are already, like let's say spreadsheets for that particular system, they were using spreadsheets. Now all of a sudden they said they want to use a database. Then it makes sense to use the normalization. So that's why for us, we followed the entity relationship diagram and we focused on it because we are building the system from scratch. So now we will talk about also the normalization. So normalization is used with we are building or upgrading or we have already existing data for that particular project. So normalization. Normalization helps. It has advantages and disadvantages because sometimes you might need to denormalize. So in this case, we have the bottom table that is not normalized. And the top two tables, they might be normalized. But let's look at both of them. Should we go with the bottom table or we should go with the top two tables? Should we keep it as one table or as two separate tables? So there are advantages and disadvantages. So one advantage of having only one table that has all this data is that it makes it faster for retrieval because we are searching only one table. So that's kind of the benefit, the only benefit. And then the disadvantages is that we might have deletion anomalies when the table is not normalized. And we have update anomalies. So if we want to delete one column, we lose data. That's what we mean by deletion anomaly. update anomaly. If we want to update one record, then it will not be updated for the other records, so that's a problem. And then we have also insertion anomaly. If we insert it, let's say only one type of data or only certain columns, then we have to fill out also the other columns that might not have a relationship or we might not have information about. So let's talk about them in a little bit. So now let's look at this example that is very strange table. So it's called strange table. So for every buyer name, we have their product number that they are managing, and also we have their major. So if you look at Nancy Myers, she is managing product 101, 100, and 101, 200. So she is managing those two products, but she has 4 entries because she has 2 measures, and we need to repeat those 2 measures for every product she manages. So that is so much redundancy, unnecessary redundancy. So now imagine that we also want to assign her a third product that is 101, 300. So what should we do now? So we will need to insert two entries, 2 more entries. So one, the first column, her name, and then the number, the SKU number, and then her first major, and then another bracket for her second major. So this is what we call it redundancy, and it is unnecessary. So that's why we need database, and we need to design database to get rid of those things. So now we need to talk about the relational model, and as we all know that Cod is considered the godfather, or he is actually the one who introduced relational database to us. He was an IBM engineer and introduced for us relational database in 1970. And I have a statement at the end after we finish normalization. There is a statement that we need to kind of remember about the normalization rules. So what we mean by normalization is that you can think about normalization as principles that guide us to design a database. So they are principles that we will need to follow. So before we go on and understand the normalization process, we need to understand those terminologies. So we are now all database designers, and we need to speak the language of the database designer, and we need to understand those terms. So those terms are very important for us. So we need to understand what we mean by a relation, what we mean by functional dependency, what we mean by candidate key, alternate key, primary key, surrogate key, foreign key, and also differential integrity, normal form, multi-value dependency. So let's start by one at a time. So what we mean by a relation? So a relation refers to a table that has certain criteria, and the criteria for that table are as follows. So this table has to have rows, its rows should contain data about an entity. So the rows or the records have to be data about that entity, not about something else. Let's say that we are collecting data about patients, and all of a sudden I included, let's say, the name of the rocket that Elon Musk fired today. So that doesn't have nothing to do with the entity, right? So in that case, that's what we mean here by rows contain data about an entity. It doesn't have entities about something criteria. So let's keep that in mind. And then the same thing for columns. So columns also, they have to have attributes or characteristics about that entity, not about something else. And all entries in the column are of the same kind. So what does this remind us of? Which integrity? So all the values in the column have to be the same kind. So is it domain integrity? Is it referential integrity? Or is it entity integrity? Domain integrity, excellent. So if the values of one column should always be the same, that means it is domain integrity. So is that clear what we mean by domain integrity? And then cells of the table hold a single value. So what we mean by that is that we can't have one cell that has more than one phone number, for example. Phone number for the first phone number, comma, the second phone number, and so on. And the reason for that is that it will not allow us, if we are trying to sort by phone number, we might not find that phone number. It doesn't make it easier for us to find that data. So we need to have, every cell has to have only one value. And that's why, if you remember, when you built your database or mind map, we say that the name of the patient has to be broken down into separate values. So the first name by itself, the middle name and last name by itself, in order to meet that relation criteria. So now, the order of the columns and rows is not relevant, and no two rows may be identical. So which integrity do you think this means? So no two rows may be identical. So is that a domain integrity, entity integrity, or referential integrity? Entity, excellent. Perfect. So it is entity integrity. That means that every row is uniquely identified by a primary key. Perfect. So now, those are kind of the characteristics of a relation. And it is very important to understand it because the first normal form criteria is that a table has to meet the criteria of this relation, which we just talked about, and it has to have a primary key. So that was kind of the first normal form criteria. So now we are good with the relation, what we mean by relation, and how we decide if a table meets the relation characteristics or criteria or not. So now this is kind of a sample of a relation. So if you look at this table here, it meets all the criteria of the table. So every column has unique name. So we can't have first name twice in this or in the same table. And every single cell has single value. And also we have entity integrity, meaning that every row is uniquely identified or uniquely different. And then we also have the domain integrity, meaning that every column has the exact same data type with different values, but the same, like the first name is all about first names, and phones are all about phones. So that's simple one. Now this one. This one is not meeting the relations criteria because if you look at the phone, we have multi-values. So we have multiple phones followed by a comma. So we said one of the criteria for the relation is that every cell has to have only one value. This one has multiple values. So that's why it violated the relations criteria. This one also, there are some rows that don't have values. So it's not meeting the relations criteria. This one should be fine because comments can be optional. And also the length of the cell value should not be a problem. Some can be long, some can be short, it should not be a problem. So now we already talked about the domain integrity. So if you need to memorize it or can review it, it's provided here in this slide. And here are some alternative terminology that we wanted to keep in mind. So when we are talking about tables, relations, and files, they are all meaning the same. And we said also an entity, a table, a relation, and a file, and a class or an object. So in this case, we can say an entity, a table, a relation, and a file. So we said we upgraded or we transformed from an entity to a table. But if someone used an entity, you can think about it that it is pre-table. It's a table, they mean it is going to evolve into a table eventually. And then as for columns, attributes, and fields, they are all meaning the same thing. And then for rows, tuples, records, or what we called it earlier, instance, entity instance. So before that evolution into a or database design. So now, to key or not to key is basically which one of those attributes, if we were given a huge data set that is spreadsheet has all those columns, and then how can we decide which one of those should be our primary key? Which one should be our key? So now we need to understand a concept called functional dependency. So what we mean by functional dependency is we need to examine every column and see which one of those columns depend on what. So we need to understand the functional dependency. So let's look at the first example here, the student ID, and then so we can read this one as the student name is functionally dependent on the student ID. And then we can also read that the dorm name, the dorm room, and the fee also, they are all functionally dependent on the student ID. Another way we read it, we can say the student ID determines student name. Student ID determines dorm name, dorm room, and fee. So those are the different ways we can read this functional dependency. So now, a determinant, so we say here we call student ID as a determinant. So a determinant can be also a composite. So basically, like what we say, the primary key can be a composite key. The same thing for a determinant, because this determinant would become actually a primary key eventually. So in order to know the grade of a person, I need to know first who they are, and I need to know for which class I am talking about. Because every one of us is taking, let's say, several classes. So I need to know the person, and I need to know the class that I am interested in getting the grade for. So then we can say the grade is functionally dependent on the student name and the class name. Straightforward. So now let's move on. And candidate key, we said it is kind of an example of an alternate key, or it's a potential primary key, and there are criteria for the primary key. So we talked about entity integrity. We said entity integrity is when we have a primary key, that means we already have entity integrity, which is met, when every row is uniquely identified. And then a surrogate key. So this is kind of helpful because it gives you more information about a surrogate key. And we say the surrogate key is helpful because it reduces, if we don't have a surrogate key, then we might have a large composite key, a composite key that consists of several fields. But surrogate key helps us kind of save that time and effort. And also it is database management system. So the database management system provides us with that surrogate key automatically. So in Microsoft Access, database management system, and also it is an application generator. So Microsoft Access provides us with that auto number as a surrogate key. So if you haven't used auto number in a table, because as soon as you enter a new record, that auto number is populated by itself. So it is a surrogate key. It starts from 1, and you can actually program it to start from any certain number that you want it to, like any other database. So the surrogate key, it doesn't have a meaning per se, and if it is visible to others, I would not recommend using it as a primary key. Like for example, let's say credit card company. Let's say they are using primary key that they give for like student ID. That is a primary key that's used a surrogate key, and it is not randomly picked. It's going to be a problem because somebody can guess someone else's ID and be systematic. But it needs to be random. But if you are not going to make it visible, usually it is not visible. Like for example, when we create a surrogate key for the assessment table, we are not interested in seeing it. We wanted to keep track for every record to be unique, for every assessment to be unique, but we are not interested in seeing what is that number for that assessment. So now you can think about it. The assessment table has to have a surrogate key to make it easier for us. And the reason is that as soon as I click on that create an assessment, it takes me automatically, already pre-populate for me the ID, the primary ID for the assessment, and pre-populate for me also the default value for date, which is now. So now I have those already. Now I can just go ahead and type right away. I don't have to bother and go ahead and select an ID or enter an ID, which might be redundant, which might be, it might not be systemic. It might be very hard for the nurse. So we don't want to give the nurse more work to do. We want her or him to just populate that assessment. We don't want them to bother about the primary. So we will do the primary. So now we can think of all the foreign key. We already talked about it a lot. Differential integrity, and we talked about it. That differential integrity is basically enforced. When we enforce differential integrity, that means the foreign key cannot have any values that are not already existing in the primary key. So that is straightforward. And those are kind of the three integrity or domain. So those are the database integrity. Three of them, they consist what we call it the database integrity. So we have the domain integrity, entity integrity, and referential integrity. Those three help us reduce errors and help us also reduce redundancy. So that's some of the benefits of having a database inside. So now let's look at this as group and decide what do you think whether those tables meet the relations criteria or not, and if not, what do you think? Why they don't meet the relations criteria? So you can talk with your classmates and decide. So what do you guys think? All right, so guys, you have an answer? So let's talk about the first one. Let's talk about the first one. Is it a relation or not? What did you guys decide? The first one, the sales one. Is it a relation? Okay. So you decided also it's a relation. Does anyone have something that you think that is not a relation? So which one? Second. No, the first one. Let's talk about the first one. We will move to the next.
So for the planet column, you could just give the planet's numbers and then type in the numbers, or you don't have to type out the planet name every time. Possibly just type out the picture or something like that.
So that actually, you are coming closer to why it is not a relation, is because remember when we say a relation, every column has to be a characteristic about that entity or about that entity. So now Mars or the planets, they don't have nothing to do with the cell table. So in this case, it's not a relation because this column is not a characteristic of the cell. It has nothing to do with cell. So remember when I give the example of Elon Musk? So I said Elon Musk, let's say he doesn't have nothing to do with the patient table. I don't really care about the name of that structure. But, it doesn't have any relation. So that's why we say the first one is not a relation because the planet doesn't have nothing to do with the cell or the content of that or that particular table. So now everyone's clear about it.
What if it was like, okay, so those values, what if it was like this sale has to do with a certain car? Would the car need to be, it would need to be on its own table?
So if it has to do with a car, that might be, I mean, at least by looking at it, let's say, although the car is not a value, so let's say put some reference here into the foreign key, you know, so it should be fine.
Could planner be planner with the sales force?
Or see a model paper.
So, or what, Lacey? So, or what? Did you want to say?
Oh no, I was just going along his lines.
But you get the idea. So you can come up with something as a reason, but the logic is that can has nothing to do with the sale. So in that case, we can say that based on the relations criteria, this one is not a relation because the relation criteria says that every column has to have characteristics or attributes or characteristics that describes the table or the entity. And in this case, the planning doesn't describe it. So now, those are the anomalies, or we call them modification anomalies that database helps us with. So we have deletion anomaly, insertion anomaly, and update anomaly. So let's think about what would happen if we have a deletion. Let's start with a deletion anomaly. So let's look at this table, the top table, and let's look at the second row. And let's look at repair number 2100. So if we decided that we are going to delete repair 2100, because that repair, for some reason, was canceled. So in that case, we need to delete the whole row if we have this table as a table in a spreadsheet. So we need to delete the whole row. So if we deleted the whole row, then we are actually deleting also the equipment type that is LACA. And we are also deleting its acquisition costs. So this is what we mean here by deletion anomaly. So if we want to delete one thing, then we have to delete some other thing, which basically is costly to us. So we don't want to do that. That's why database management or database design help us separate those two into two different teams. Remember when I talked to you about the teams? So we said that the sixth grade teacher who was providing for the English teacher always told us, when you are writing a paragraph, write every paragraph about one theme only. So the same thing about normalization. You can think about it that way. So now, if you look at this table, there are two themes, right? There are exactly two themes. One about repairs, and one about the product or equipment. So can we think about it that way? Right? Does it make sense? Two themes. So if we can combine those two themes, then it's problematic. And one of the problems is what we call the deletion anomaly. So another example of modification anomaly will be the insertion anomaly. Let's think about insertion anomaly. Let's say that I wanted to include or to insert a repair, one repair. And that repair, let's say I want to call it 2600. Repair number 2600. Choose kind of the last one. Let's say that it is number 7. So I want to include that repair, and I have a repair date, and I have a repair cost for it. But I will have also to populate the item number, which I might know, because I'm repairing something, and I should know the item number. What about the equipment type? I should be able also to know that. What about the acquisition cost? In that case, I might not know the acquisition cost because I'm looking at the repair. I'm not a management person. So in this case, this is what we call it the insertion anomaly. So it's a problem. I might read that blank, and that's a problem. So we might not charge people because we don't know what this is its acquisition cost. So that's another problem that can occur if we have non-normalized tables. So now let's think about an update anomaly. So as an example of an update anomaly is actually number 6 in the last table. If you look at record number 6 and repair number 25 and acquisition cost for record number 6 in the bottom table, it has, let's say we wanted to update the acquisition cost for drill press to 5500. So in this case, we were able to update it only for the last record. But now, if you look at the other ones, it's not updated. So we need that case, this is problematic. This is an anomaly. And only database help us do that. And that can be the referential integrity, for example. Using referential integrity can help us if we to update it only in one place and it will update it for us in all other places. So that's where referential integrity comes to place and cascading happens. So database design, why they use Microsoft Access, after what you are designing for your project can be applicable to any database management system, whether it's Oracle, SQL Server, MySQL, DB2. So it is implementable in any of those database management systems. And it is very useful because we are getting rid of those. And normalization, which is the normal forms, which is the principles that guide us to come up with database design, has multiple forms, but the most common ones are the first, second, and the third normal form. So we'll talk about those three ones. And we will focus on those three normal forms. And next week also we will go over some examples as well that we will do in class. So, but for now, let's understand what we mean here by the first normal form criteria. The first normal form criteria tells us that a table is in the first normal form if it has the criteria for relation and it has a primary key. So that's kind of the first normal form. If we have a table that has a primary key and meets the relation criteria, then automatically it's in the first normal form. So the second normal form tells us, or criteria for it is, a table is in the second normal form if there is no partial dependency. Remember that the functional dependency we talked about? So if there is no partial dependency, you can think about it this way. If we have a composite key, that means we have more than two fields that are primary key. So in that case, if we have a composite key, then we need to think about whether one of the non-keys depend on only one of those composite keys or on both. If every non-key depends on both those composite keys, then we say that it is meeting the second normal form. If we have one non-key that depends only on only one part of this composite key, then it's not meeting the second normal form. So in that case, we need to separate those or partition those that depend only on part of that composite key into a new table. And then we can decide where to put the foreign key based on what we talked about earlier. So now the third normal form is telling us there should not be transitive dependency. So what we mean by transitive dependency is that no non-key should be dependent on another non-key. So meaning that if we have a field that is not a primary key, that depends on another field that is not a primary key. In that case, we need to, it's not meeting the third normal form, and we need to separate that. Create a table for it, separate. So now let's look at some examples here. But before we move, this is kind of the statement that everyone should make after we normalize our tables. So I swear to construct my tables so that all non-key columns are dependent on the key, the whole key, and nothing but the key. So help me count. Right? So this is the statement that we need to follow in order to see that we are meeting the normal form. So this is the example that I have provided to you. So you can think about it. It might be different, but let's assume this is kind of true. So the first, when we say here before the first normal form on the top, we didn't have a primary key. So now when we are looking at the first normal form, which is the second column, we have a primary key that is repair number. So now can we say this is first normal form, and the criteria is that it has to be a relation and it has to have a primary key. Do you think those two are met with the first normal form? So we can say yes, because we don't know the values yet, but we can assume that yes, since we have a primary key at least, we can say this is meeting the first normal form. Now, the second normal form. What was the criteria for the second normal form? No partial dependency. Do you think, do we have any partial dependency for this table? So let's look at the column that says one or one normal form, or the first normal form. So in that table, we see that there is a partial dependency.
On the grade or the equipment?
On the first normal form in the top, that is here, the equipment is here. So we say the partial dependency means that if an key depends only on one of the composites, one of the partial, depends on a partial primary key, partially. So if we have a composite key, that means it might have two or more parts of a primary key. So if a non-key, one of the non-keys, depend only on one of those composite keys, then it is what we call it partial dependency. But here we have partial dependency. We have a non-key that depends only on one part of the primary.
We have two composite keys.
Excellent. So that's the key. So since we don't have a composite key, now we don't have partial dependency. So we are reading the second one. Does that make sense? Everyone is clear? So what she said is that when we look at the first normal form row on the top, we don't have a composite key. That means we don't have partial dependency at all. Because we have only one field as the primary. But if we have a composite key, then there might be a partial dependency. So now, very good observation. So since we don't have a composite key, that means there is no partial dependency, meaning the second normal form. Right. So now we are good with the second normal form. What about the third normal form? So the third normal form, what was the criteria for it? Transitive dependency, which means
A non-key is another non-key.
excellent. So do you think we have, let's look at the second normal form column. Do we have a non-key that depends on another non-key? So equipment type depends on the item number. Excellent. Acquisition cost also depends on the item number as well, right? So now we can say, well, it doesn't, the one that in the column that says second normal form, that table doesn't meet the third normal form because we have transitive dependency. We have a non-key that depends on another non-key. In that case, when we have this situation, we need to separate those values that are dependent on another non-key and create their own table. That's what we did. We created a table, we called it equipment. And its primary key was the item number, which is the dependent, or what we call the determinant. So we call the item number as a primary key, and then equipment type and acquisition cost. Now, why did we put the item number in the repair table rather than on the equipment table?
I'm sorry, what was the question?
So why do you think we put the foreign key, which is the item number, we put it in the repair table rather than putting the repair number in the equipment table?
I was gonna say, because like there's gonna be equipment that might never get repaired. Like maybe there's something that it's worth more, it's easier to just like replace, so it would never get repaired.
Okay, very close. David?
I was going to say basically the same thing, phrased a little differently. Everything in the repair table would have an item number, but so every repair would be an item number listed. But like you said, not every item would need to be repaired, so that's why you showed it on that side. Instead, do the
So what you said is very close. Let's look at it from a cardinality perspective. So yes, so which one is the mini side, which one is the one side? Excellent. So every equipment might have at the maximum many repairs, because the same equipment might have many rows with the repair table, many rows. as a rule of thumb, if we have a one-to-many relationship, we put the foreign key in that. Anyone remember? In the many sign. So if we have a one-to-many relationship or one maximum cardinality, one-to-many, always the foreign key is in the many sign. So everyone is clear about that? Very clear, straightforward. Now let's look at the student table. So let's look at the student table. And the same thing, kind of it has the same example that we had up. But let's look at the courses, to the bottom one. So where it says courses. So the courses now, we have a composite. So can we say that the courses, the first column of courses meets the first normal form criteria? Yes. Why? Because we say the criteria for a relation, for a first normal form, it has to be a relation and it has to have a primary key. Now, do we have a primary key at least for the courses? First column? Yes. It is composite. As long as it is primary key, we are good. So now it meets the first normal form. Now, the second, so let's look at the same column, the first column for courses. When we look at it, before we move on to the second column, let's look at it. Now, do we have a transitive dependency? Not transitive. Do we have partial dependency? That means, do we have any of the non-keys depend only on one part of the primary key?
Yes.
So yes. So which one?
I'd say course title probably only depends on course activity.
Excellent. That's one. Very good. Anything of any other one? Instructor name. Yes. So the instructor name depends on the course ID. So excellent. So now we kind of separated or partitioned those parts that depend only on one part of the primary key, and we created their own table. And we kept grade, because grade depends on the composite. You need to know the first name and the student name in order to know the grade. So that's why we separated it into two tables. Now, can you tell me also the same reason why did we put the foreign key, which is, so where did we put the foreign key? Do we have a foreign key? So we have a course ID. So actually the common key is the course ID. So course ID here is a foreign key in the grade table, we can say, or the course grade table. So it is the composite key, which is the course ID and student ID. It is a composite key. And the course ID here also by itself is a foreign key for the course table, right? So everyone agrees on that one? Is it clear? All right, so now, when we look at the second normal form column, or actually the second normal form column, now is there transitive dependency in any of those tables in the second normal form? Yes. So which one has transitive dependency, which means a non-key depends on another non-key? So now this is a good example of what we call a transitive dependency. A non-key depends on another non-key. In that case, we create a table for it. We separate it from that table. I will create a table for it for it just to connect those two tables. So what was the foreign key that we used? So we put the instructor name in the first table. So now let's think about the logic of it. Does it make sense? So the relationship between course and instructor. So how can you read that now? Anyone wants to read it for us? For the course and instructor. If you can read the maximum functionality for us.
Instructor.
And from course to instructor.
Courses. Top right.
So every course, so the best way is to read it, we start with the read to make it easier. So every course, we start by one. So, so you include the minimum cardinality, which is fine. So every course is start by one and one. Instructor at maximum. And then every instructor teaches many courses. So now, why did we put the foreign keys in the course table? Excellent. So it is the mini size. So when we talk about the cardinality, we say every instructor teaches many courses. So the mini courses, so the mini is in the courses. That's why we put the foreign keys in the mini size. Right? Everyone is clear now how to do that? We will review this also next week. So we will stop here. And before we stop, let me take you to, I will let you read the rest. And this one here kind of gives you the details how to normalize that, but we will think about it in terms of fees, so normalization, and we will do some examples like the ones that we did today next time. But before we move on, just kind of a reminder what we need to do for this class. So we will read chapter 1 from, what's the name of the author? Crocky? How do you pronounce his name? Crocky. So chapter 2. And then the homework will be milestone, the logical model, and also Microsoft Case 6. So for the logical model, if you need to meet with me as a group, or you want one of your team to meet with me, I am available. Just send me an email. I can make time for you. But usually my office hours are Tuesdays. So today's Wednesday. Tuesdays from 1:30 until 3 in the normal campus. And here I also come, if you notice that I come and I sit in those offices, so if you want to see me before class, that might be too late. Maybe I can change it by that time. But if you want to meet with me, I can meet with you during my office hours, or send me an email that I will, if I am in my office, I will be happy to meet with you.
And the logical model is that just the diagram?
It is the ARD diagram, and also you will need to decide where to put the foreign keys. So it has the cardinalities and the foreign keys.
So do you want us to just do the dotted line underneath the foreign key, and is there a certain
Very good. Very good. So that's a good question. So if you wanna, so how to put it? For example, let's say that you put the foreign key. You can either put the PK in parentheses in front of it, or if you want to underline it, that will be fine as well, and put a primary key, that will be fine. As long as anyone can read it, from an outsider can read it and understand this is a primary key, this is foreign key, and so on.
If you use the chart, they have the like options to mix that.
Oh,
Have you used it?
Side, you put your keys, like PK, and that's the primary key.
So yeah, let me go quickly through Lucy chart. Let's see. Kind of to, because you have to add it before. It's not recognizing mine. So anyone, David, can you log into your Lucy chart, please? The licenses. So we all should have updated the licenses. So now we should have the full options for Lucy chart. So she might have used. Let me.
I'm not sure.
Okay, so that's just this. So let's say the education one, and then your student. So I'll select the student one. personal. So we are home personal. Okay. Okay. So let's say we will start. We'll start blank diagram, and let's see if this, because I need to add. So let's say this one here. Skip steps. So we need to go to shapes, and then from shapes you will need to select where it says entity relationship diagram. So we need to select this guy, entity relationship diagram, and then say save. Now I should see it here. So you can select either one. So it's up to you to select either this one or this one. So this one will be helpful. Let's say this is, you want to call this one is patient or resident. And then let's say this is a primary key. So which one would you use, David? Would you use this shape or the other shape?
I would use that.
This one?
Yeah.
And then if it is not a primary key, then you can just delete this one here. Oh, you can just
Yeah.
you can just highlight it and delete, and this one. Yeah. So if you wanna put, let's say this is a foreign key here, FK.
Can you draw the lines and the cardinality with that?
Oh yeah. So the cardinality is very good. So let me say that I will assume this is a different, another. Let's say here we have gender. So every patient has one and only one gender versus every gender belongs to many patients or residents. So now the cardinality comes from here. So let's say that I want to use this one. So let's see here. So here, and then you can modify it. You can modify it from here. So this is the endpoint and this is endpoint. So this one, so every patient, every resident has one and only one. So I need to change this one to one and only one. So one and only one is this one, right? And then this side endpoint, I can put it, every gender belongs to one or many, or what do you think? It doesn't matter, 0 or many. So either one will work. So use your logic as long as you can. If I asked you, you can justify it, should be fine. All right?
For milestone 3, is this a team turn or?
It's the team. So the rest from milestones from now on are all team. So the only individual one was the mind map, and the rest will be all teams. So now, is it kind of clear how you can do it? Yeah, very easy, very simple. And this one you can use it. So talking about the open source, if you want to use, there is another one called Glyphy. Glyphy, it's an open source. It's if you want to use it in your organization, also it is open source free. And Lucidchart, it has limitations, as you have seen. And Visio, you have to buy that software, and it's expensive. But anyway, so now let's take a break, and then let's meet at 50. So we'll meet at 7:50.
Do we have another lecture thing, or are we coming back to take the test?
So we will do. So we will continue, and we will work with week 4 clinic database. So let's download this guy. So you should have the notes also with you that we will follow. So I just want to highlight some of the nice points here that you are going also to utilize for your project. So one thing that is really helpful and important is that we have different controls that when we are creating a form. Let's say that I want to create a form using blank form, and I just want to show you where you can find those controls. So the controls, they are basically under design, and those are the controls. So whenever you are using this control area, make sure that this one where it says use control wizard is always selected. So make sure that it is selected, because if you unselect it, and let's say that you want to create a button, it will not give you the pop-up message or the wizard where you can create a button, for example. Or if you want to create a subform, it will not give you that wizard that will take you through the subform. So what I did, actually, I created, first I went to create and then blank form. And then when you do the blank form, then you will be able to see that under design, the controls. Okay, so now let's say that I'm interested in adding a text box. So we will show the difference between a text box versus a combo box. So if I clicked on this text box and then I can click here, so now I have a text box. Let's say that I want to activate it. This is how the text box will look like, and now I can enter anything. So that's kind of one thing. It allows us only to enter. It is a text box where you enter something. So you can't do much with other than that. So now let me go back to the design view or layout view. It doesn't matter. I can go to the layout view. Now let me add something called combo box. So the combo box is this guy. So this guy is the combo box. So I can add this guy somewhere. Now it came up with a pop-up message. So that's why we need to make sure that where it says the control wizards is highlighted earlier that I showed you, it allowed us to use those wizards. So now the wizard is popped up, and now it is asking me what do I need to do. I will say yes, I want the combo box to get values from another table. So I will go next. Let's say that I'm interested in showing the first name, last name, or the last name or first name from the patient table. So I will go next. I will select the patient table and go next. Let's say I want to show, let's say, the last name of the patient table and also the first name. All right, so I'll select both of them just kind of for illustration sake. And then I want to order them by, let's say, last name. Go next. Now I can show only the first name and last name, or I can choose also to show the primary key by unchecking or hide the key. So now I can see all of them. Or you can keep it, only the first name and last name will be fine. I'll go next. Let's say I want to call this, I'll just keep it as what label would you like? So I will keep it that one, just to illustrate for you. So now let's activate this form. So when we activate this form now, I have options. I can either start typing. So I can start typing by, and so which table did we say? So I can either type, so I need maybe to select only one field because now it is confused. But let's say that I wanna, is there a name that is easy? Cruise. So let's say that I wanna type Cruise. So now Cruise is there, but I can also select him from here. But actually it is saved. But let's do it again and selecting only one field. So combo box again, and then we will go to patient, next, patient, and let's say that I'm interested only in the last name. Next, and last name, next, next, and next. It might save for me only the ID, but at least now I know which one that I am interested, which patient I'm interested in. Or let's say that I'm interested in B. So now, if I start with B, it automatically shows me that. So let's say with C. Now I can start typing. So you get the idea what we mean here by combo box. It has two features. You can either start typing or you can select from the drop-down list. So that's the beauty of drop-down list. And the drop-down list helps us, especially when we are using the lookups. So we can use combo box for a lookup for a primary key from a different table. So especially for foreign keys, combo box is very handy. So now that was the first thing. Second thing that we want to look at is that we can also edit the lookup. So in your example, let's close this one. So there is a relationship or there is a lookup that we built that was under billing table. So if we go to design view of the billing table, we created a lookup for this guy. And remember the invoice item, we created a lookup for it. So now in the book, it asks you to change the lookup. So you can change it from general to lookup here. and then it asks you to change it from combo box to text box. So you can do it from here. So that's kind of one, if you are not sure how to do that, so it is from here. For me, I will keep it with combo box. Combo box is much easier because now the combo box allows me kind of to select from a drop down. Especially it's handy when I have a form. So now another thing is that we can modify the relationships. So if I go to database tools and then I go to relationships, you will notice that after we created this lookup field for the billing table, it was invoice item. So when or invoice item ID, when we created that lookup, now it is not showing us the one-to-many relationship here, and it is blank. So now let's enforce that. So to enforce that, to show the one-to-many, we can highlight this line and then right-click on it. So right-click on it and then make sure that it shows edit relationship. So we right-click on this line and edit relationship. Now we have this screen. Now we can enforce referential integrity, the one that we talked about earlier. So the foreign key values have to be exactly like the primary key values. And then cascade updates. So those are the two that we will select and then click OK. Now we have a one-to-many relationship. Now we are cascading. If I changed anything in the primary table, which is the invoice item table, anything I change in this table will be reflected in the billing table. So that's what we mean by referential integrity and update cascade updates. So now let's move on. And also it provides us here with, if we want to print for documentation's sake, let's say the relationships. So we can go to print the database relationships by going to Design tab, and then where it says Relationship Report. So we can actually click on this relationship report here. Now it looks beautiful. It shows us, we can save this as a report, and it shows us the tables and the relationships between them. So you can save it as a report if you want, RPT, and you name it, whatever you want. But for me, I don't want to save it for now. And another thing is we can do also documentation. So we can, using the documenter, so if we go to database tools, so the database tools, and then we have database documenter. So let's click on this database documenter here. And let's say that we are interested in the table visit, and let's go to options. After we select the table visit, let's go to options, and then we want to select, let's say, no properties. We want to just say select the names, data types, and size, and names and fields here for index. So, and then we'll say OK. And then we will say another OK. Now it creates for us kind of a really nice report, data dictionary, and it also shows us the relationships, whether it is one-to-many and so on, and which other tables that the table visit is connected to, and the relationships between table visit and other tables. So you can save this as well as a report, or you can save it as PDF, so whatever you want to save it as a documentation. So now there are different types of forms as well that you can utilize. So the ones that I personally prefer and always use is the blank form. I like it a lot because I can create it in layout view or design view. And another one is very handy is the form design. Also, it's really nice. But there are some other forms here, but let's look at more forms here where it says more forms. So for this one, let's select a table. Let's select here the visit table. Let's select the visit table and then go to where it says more forms. So while the visit table is selected, now you will see all of them active. So let's start with multiple items. Click on it and see what we have. It doesn't look really nice. It's really bad. I don't like it. So let's look at another option for more forms, data sheets. Data sheet is basically similar to the table, so it looks exactly like the table, so it doesn't have any much benefit. So now let's go back and create another form using the more forms, split form. Some people might find it helpful to use the split form. So the split form looks like this. So it has nice input here, and then you can navigate, and then data sheet in the bottom, and so on. Some people might like it this way for some reason, but for us, we will stick to the previous ones. The you know the blank form is really nice. So now let's say that we want to modify this form that we created in split form. Now one thing is this layout, it will not allow us if we are trying to move, let's say, this guy somewhere else. It doesn't allow us to do that because we have layout here. But let's say that we want to modify the date of visit. We want to just kind of align it a little bit. So let's reduce this guy. So we will reduce all of them kind of until this way. That way I can get the reason and the comment and put them somewhere here on the right side. So now what I need to do is I will need to select the reason label and here the reason box, and then the walk-in while I am holding the control button and then selecting the others with the mouse. So the comment and here. So I'm selecting those guys. So while I'm selecting those guys, now what I can do, I can right click in any border, and then I say layout, and then remove layout for those boxes. So I will click on remove layout. So now I should be able to move those guys. So I need to select now again the reason label and box, and the comment label and box. So only those two guys. Now I can just drag them and move them somewhere here. All right. So now I can move them there. The walk-in, I can also move it or just keep it there for now. So now this is one thing. Those of you who have taken any classes in programming, you might have learned about anchoring. So any one of you have learned about anchoring when you took a programming course? So anchoring, whether you are creating a website or you are designing a form using any of the programming languages, whether it is Java, C++, or Visual Basic or C Sharp, it is recommended that we use anchoring. So what anchoring does is if your screen resolution is different when you are presenting it in another computer, sometimes the screen would look like all over the place, it's not aligned correctly. Anchoring helps you avoid that problem. So for me, I developed a software one time for a department, and I used anchoring. And it was really smooth. It was really nice because I used another old computer at that time when I developed that. And that computer, when I ran it first without anchoring, it was all over the place. Kind of some of the boxes are inside each other. But anchoring will help us. So let's do anchoring for the walk-in. And so let's select the walk-in and its check mark, and let's do anchoring for it. So we will go to arrange after we select those two guys, and then where it says anchoring. So from its name, anchoring, you know, when you are in a cruise, they stop the cruise by throwing the anchor, right? To make it firm. It doesn't move. It doesn't go too far from what it is. That's exactly what it is here. It makes it stable in that particular corner. So now let's go to anchoring and then put it in the bottom left. So now whatever resolution I show this database or this form, it will be exactly in that particular bottom left. The same thing, we can do this one. Also highlight those guys and say top right. Oops, I didn't unhighlight the one. So I need to highlight only those two guys and then anchor top right. And then I need to highlight comment and sneeze, and I can anchor it in the bottom right. So now whatever I do in any computer, it will show really nice. So now let's also think about or talk about what we mean by bounded versus unbound, bound versus unbound form. So some forms, they are basically, they have a source. Each source is a certain table. Then we can call that form bound object or bound form. So it is bounded, or it is based on a existing table within our database. But if we have a form that doesn't have any source code or any source, that means any table that it relies on, then it is called unbound. So what would be a good example of a form that is unbound? Main menu, switchboard. So if we have a main menu or a login, so a login form, it is a form, but it doesn't have any source for it. So the record source doesn't have. But if I create a form from here, let's say that I have a form that is already here, let's say patient form. So and I go to here and I go to design view, and then I go to property sheet. So when I go to record source, I see that it is based on the table patient. So in this case, this tells me that this form is bounded, or it is bound form. So because its record source is table patient. But if I created a form that is blank, and now I go to design view, and I go to property sheet, I don't see any record source, so that means this is unbound. Very clear, very straightforward. So now let's create a custom form using design view. So let me close this guy and this guy. We will create a custom form really quick. So we will go to create and then blank form, and then I will go to design view, and next I will go to design tab, and if you don't have this one, you can just click on add existing fields. So let's click on this add existing field. Now you will see this option where I will click on show all tables. So now all the tables are presented to me, and I'm interested in creating a form based on table visits. So I'll click on this plus sign. So now I need to select the visit date. So I'll double click on it. And then again, I'm interested in the table visits. So I will select the date. What else is next? So I will select what else? So visit date and then patient ID. So patient ID, double click on it. And then I need the reason. Double click on the reason and then comments. And then what we have, the walk-in. Walk-in next. So now what I will do, I will move the walk-in from here, and I want to move it somewhere here. Now we can align it with those two guys. So to align it, what we can do is actually to select it. You can either align it using your own measurement to make sure that they are in the same, or what you can do is select this guy and make sure that you select this guy and this guy, and then right click on them, and then where it says align, you can say top. So now they are aligned in the exact centimeter. So now that we have this form, now let's say that we are interested in deleting this patient ID. Instead, we want to create combo box for patient ID. So let's say, so we will right click on this guy and delete it. Now we can just go ahead and drag a combo box from here, and we will place it instead of that particular ID. So I deleted. So did I go too fast? So what I did is I deleted that. I right clicked on that patient ID text box. So I deleted it, and then I want to create a combo box instead of it. So then I will just go next, and then I need to get this guy from Did I go too fast?
No, I click on the wizard thing, but it's not.
It doesn't pop up?
Like it doesn't give you the wizard option. It just puts the box there.
Okay, so make sure that it is highlighted. Let's click on it one more time. And then let's do it. So let me, it work? Okay, great. So now we will click on the combo box. I'll drop it here. Then the wizard will come. Then we'll go next. So now it is asking us to select the patient ID, but from which table? So the patient table. So we'll go to the patient table. Is this right? So I'm doing the underline, the second underline. So it is the second underline which says adding combo box to a form. So I want to do combo box wizard and then go to patient table. Next. Now it is asking me to select the patient last name, the patient first name, and patient ID. And then go next. And they want us to also to sort by last name or patient ID. It should not be a problem. Go next. Then we can just keep it this way. And next. And then where it says store this value in this field, I can just select here the patient ID. So I'll say next. And then I will just, you can call it here patient ID. All right, so then I will finish. So now if I navigate, I will see here the patient name instead, and so on. But you got the idea. I can make changes, but I would not do this for any. This is just for illustration, because here I can mess up the records because I might select another patient for it. But this is just for illustration's sake. So now let's say that we want to add a title. To make this form nice, we need a nice title for it. So we will go to design view, and then we will click on this title here. So design view, under design, I will click on title, and automatically brings me a nice title. I can call it here visit table, for example. All right, so now when I activate it, it looks beautiful to some extent. We can make it even more beautiful. Later on, when you create your software or your app, it's gonna be way much beautiful than this one, because we are learning little by little. By the time we finish module 10, you will have a lot of resources. So now let's say that we want to create a subform. So now we have the table, and in order to know which subform will work really well for a visit table, so for the visit table, we can use table billing as a subform. So the billing table is a nice subform for it. So let's close this guy. So now let's create a subform, and I will save this one as form 1 for now, for illustration's sake. And then I will go to design view, and then I will follow the steps here where it says adding a subform. So to add a subform, so it says that we need to go to the design tab, and then from the design tab, I need to go to the controls. So if you look at the controls, there is, this one is the subform. This is the shape for subform. So if you hover over it, you will see that it says subform. So I'll click on it, and I will drop it somewhere here. I'll drop it here. Now I have a wizard, and I will follow the wizard. So it says use existing tables and queries. So I will say yes, next. And now it is asking me to select the billing table, right? So it's asking me to select the billing table, and it says that I need to select all of the fields in the billing table except for the visit ID. So I will click on those two greater sign to move all of them at once, and then I will get the visit ID back. Did I go too fast, anyone? You sure? Okay. So then I will go next. Now I will make sure that this choose from a list that it looks like it is connected. So that's a good sign. So I will keep this as is. I will go next. So what does it say? The link you selected cannot be used. Was created based on relation.
You have to choose
Oh, this one? Okay. So we'll go next and finish. So now let's say, no, none, it should not. Because none shows all of it. Why it is not doing this? That's very strange. So let's see. Did it give you any errors for you? If you, hmm. So let's try it one more time. Use existing tables and queries, and then table billing. So we will keep the visit ID and see. Oh, cannot be used. This link was created based on relationships between. Let's look at the relationships. What is in the relationships? That's strange because I just did it before I came. So let me I will create a video for this one and then I will send it to you. So this one is really helpful, especially when it asks you to create a calculated control. So for the calculated control, basically it wants you to open that subform and create a sum function to calculate or to add up all the values, the invoice amount, and then another control where you will calculate the count of those rows. And then you can show it in the main form. So I'll create a quick video. It seems to be this data set that I posted here is not working correctly for some reason. So I might have posted the wrong file. But let's see what else, if there is anything that we can do. Let's say, so another thing is that we can look at is the tab key. So one thing that is really helpful for data entry is when you are using the tab key. So when you click on the tab and it moves from the first to the second, it is very handy, especially when people are typing. So to do that, you can go to design view. Let's say that you created a complicated form and the tabs are not in order. If you click the tab, it goes all the way to the bottom and then goes back up and goes all over. And you want to fix that, you can go to design view and then you can click on where it says tab order. So the tab order here. And then you can either make it automatic if you want, or if you don't want it to be automatic, what you can do is you can just go to design to the property sheet. So you can go to the property sheet and then click on every text box. And where it says other, you will say where it says the tab index. So the tab index. Another thing is the tab stop. So as soon as you open the form, the tab stops at this particular text box. So that's where it says tab stop is yes. And the tab index usually starts from 0. So this is 0, and the next one is 1, and so on. So those ones are already clear for us. So basically they are in the correct order. But you got the idea. So if you create a form and you want to order it, you can order it from other and then the tab index and so on. So we will stop here and then I will send you a quick video for how to how to create a main form and a subform.